I can be ignorant.
Okay, look at what we've got started here. This says 7/4 plus 3/4. So we're adding and subtracting rational expressions today, which means we're adding and subtracting fractions.
Would that be 10/4?
Say that again.
Would that be 10/4?
Yes, it would. So what I've done here with this one, this has got no variables or anything like that. I just want us to review over some important truths in the beginning here. When we add or subtract with fractions, we have to have a common denominator. So that's the first thing you're checking for. You cannot add or subtract if the bottoms aren't the same if you don't have a common denominator. So on this little warm-up problem here, they both have a 4 in the denominator, so it is the same. So that means you keep that denominator, and then you just do whatever the sign says to the numerator. So the sign says to add, so 7 plus 3 is 10. Okay? Now, after we get that done, we look to see if we can reduce it any.
10.
So what can I divide out?
5 over 2.
Okay, divide a 2 out of both top and bottom, and that would be 5 halves. Easy schmeezy. Okay? Alright. Now, same problem here. What if this said 7 over 4x plus 3 over 4x?
You can just add it because they're still the same.
Okay. Even though we don't know what x is, like Grant said, it's still a common denominator. So 4x and 4x means my denominator will be 4x. 7 plus 3 is again 10. Now can I reduce that? Yep, same as before. It would just be 5 over 2x. Okay, everybody okay on that? One more little warm-up one before we get into some more fun stuff. What if I had 2x over x plus 6 minus 5 over x plus 6? That's a 6. What are we thinking on this?
It would be 2x minus 5 over x plus 6.
Very good, Grant. So my thought process I'm going through here is even though the denominator is a binomial, it's got 2 terms, it's still the same on both sides. X plus 6, x plus 6, that's common. So my answer will have an x plus 6. Okay, then on the top, I've got a 2x and a minus 5. I don't know what 2x minus 5 is, so I just leave it like Grant said, 2x minus 5. That's it. Fabuloso. Everybody good?
I think we should review some.
That's what we just did. Alright, now I've got 7 over 9x squared plus x over 3x squared plus 3x. Alright, so we just jumped in the deep end right here. Obviously not a common denominator. 9x squared is not the same as 3x squared plus 3x. So that's our job, is we have to get a common denominator before we can combine these. So when I'm looking for a common denominator, this is where we're going to go back and use some of the stuff that we did on Tuesday. We want to break down things that we can to see if anything has the same parts or not. So we want to factor what we can. So on the left side, 9x squared, that's just a monomial. Not a lot to factor out of that, so I'm going to leave the 9x squared. But on the right side, I can factor that binomial. What's the first thing you're supposed to check for every time we factor? It's got some initials.
GCF.
GCF. What's the GCF of this denominator? 3x. Very good. So if I take a 3x out of that, that would leave me with an x plus 1. Okay, so what we've said, I'll write it over here on the top side, what we've said is that 3x squared plus 3x, that's the same as 3x times x plus 1. I just factored that, right? Took the GCF out. You don't have to write that down, I'm just showing you what we've done so far. Okay, we still, even though we factored that and did some good thinking there, we still don't have a common denominator. Alright, think back. Oh, hold on, you're ahead. Think back to when you did a problem like this. What would the common denominator in this case be? 15. Where does that 15 come from? 3
3
times 5. So that's the same thought that we're going to have when we got something ugly like on the smart board. We're going to look at, so we would say this is the same as, we know that's 15, but that would be our common denominator, right?
Right.
Okay, so that's the same thought process we're going to go through. This one only had the 3. We had to also multiply it by 5.
So why don't you just put 15?
Because
Well, you have to multiply the top as well, don't you?
yes, you do. This one only had the 5, so we're just going to put 3. Because when I get into the bigger, more complicated ones, Riley, if I go ahead and multiply that, it'll get to what Chloe's talking about. I won't be, if I just put 15 there, I might not know what I multiplied it by, so that might make me forget to multiply it by the top also. Now I can see, okay, it was just a 3, I multiplied it by a 5, so I know to do a 5 on the top also. It was just a 5, I multiplied it by 3, now I'll know to do a 3 on the top also. Eventually I will multiply it, but that way I know what to do on the top. And that was good, Chloe, on that. Okay, so here it is. What we know, just like over there by River on the dry erase board, this 9x squared has to be a part of my denominator. Okay, so over here on the right side, the 3x times x plus 1 has to be a part of my common denominator. Just like I brought down those 3's and 5's over there, I just brought that down. Okay, now, what does the 9x squared need from this right side? If it's over here, it's got to be over here too. So what's over here that I need to put over here? Okay, the x plus 1 in parentheses, that's correct. What about this 3x? Wouldn't 3x be a part of 9x squared?
Yes.
Yeah. So I don't have to put that over here. Okay, what does this side need from the left side? It's already, we've got x plus 1, we've got x plus 1, but I don't have a 9x squared. So what can I put on this side? Another 3, what? X, right? And you can put it anywhere. I just have more room on the back, so I stuck it on the back. All right, now I know this is a little bit new. We're going to work a lot of these. Don't panic on me yet. Actually, we'll do it again some more tomorrow. It takes that much attention. 3x times 3x is 9x squared. That's what we did over here. Okay, now I'm going to bring this 7 down. Y'all follow this. This is where the important stuff happens. This already had a 9x squared, so that's not new. What's new down here that wasn't up there? So if I multiplied that on the bottom, I got to multiply that on the top. Okay, now I'm going to bring this x down. It already had all of this piece where my mouse is. What new piece did I put down here on the bottom? So I got to put a new 3x on the top. Okay, now my denominators are the same, even though the one on the right looks a smidge different. Go ahead, Michaela.
Why would you put the x plus 1 on top?
It already had it. I didn't put it new on the bottom. So I brought down what was there. And then anything new, it already had this 3x, check, check. Already had this x plus 1, check, check. Here's the new thing I put. So, okay, good question there, Michaela. Everybody else ask me if you're not sure on where something came from. And like I was saying, on the right side it looks a little different, but if we were to multiply those 3 x's, that would be the same. So it is the same. So now my common denominator, I got the 9x squared, the x plus 1. Okay, this makes 7x plus 7 plus 3x squared. Can I combine any of that stuff on the top? No, one of them's a squared and one of them's not. So can't combine any of that on the top. If I could factor it and be able to ninja something out, I would. Am I going to be able to factor that out and ninja anything out? My angel's right? Nope. So that's it. You're done. Now, cleaner might be to write that in standard form. Put the x squared first. So you might see it as 3x squared plus 7x plus 7 all over that denominator. That's another way it could look. Another way it could look would be to distribute that denominator. 9x cubed plus 9x squared. But none of those are any better. Those are all the same answer as the first one we got. So that getting that common denominator, that's the hard part. That's what we got to pay careful attention on.
The greatest common factor thing always confuses me. Like I get like what you're doing, I just
Forget to do it.
the parenthesis. Will it always be like x plus 1 in the parenthesis?
Attention students, chamber choir needs to report to the choir room. Chamber choir, report to the choir room.
It'll be whatever. The reason it was 1 is because we took that whole thing out. But if that had been a 6x there, it'd be a 2.
Okay. Okay.
All right, let's try some more.
It just makes me like really. My brain can't handle all the numbers and letters.
Alright, we got 8 over 12x squared plus x over x squared plus x. So before you start trying to guess what your common denominator is going to be, you need to factor, you need to see the parts. So that way you'll know what parts to put on the other sides. So 12x squared, that's a monomial, that's going to stay 12x squared. Okay, what about x squared plus x? How does that factor? What's the GCF? X, so that'll leave you with x plus 1. Okay, now we should be able to look at this. Let me go ahead and bring down my 8, my x. Should be able to look at this to form our common denominator. Okay, we know it's got to have a 12x squared. Grant's got it. And we know it's got to have an x plus 1. Grant's got it. Now let me ask you a question here. Whoops, I forgot an x on that side. 12 squared would be 144, you dumb butt. 12x squared. Okay, let me ask you this question. I brought the 12x squared down and I put it on both sides. I brought the x plus 1 down and I put it on both sides. Why did I not bring that x down?
Because
it's included here, right? Okay, so if it's in a monomial and it's already there, you don't have to repeat it. I could, but then that would just make my problem be longer. And
So now you would add your x plus 1 on top too.
okay, so on the right side with the 8, that's the left. I was standing here, so it was on my right, but I'm trying to help myself look better, but it's bad. With the 8, there was already the 12x squared down there, so the new thing that I got to multiply top and bottom by is x plus 1. Okay, over here with the x, I already had that x. I already had that x plus 1, but I didn't have a 12. And this x changed to an x squared. So I need another x up there too, don't I?
oh.
Now, could I have just written 12? Could I have just written 12x instead of putting it in the double parentheses like that? Of course. Well, there's a table there. Of course. I'll just sit down since I'm messing everything up. All right. So now, go ahead, Chloe.
This doesn't really have to do with. Did you see my drawing?
Yes, I did. It was fabulous. So somebody added a body onto it throughout the day. But
What?
so I didn't see just the head. Is that what you did?
Yeah,
just
I
the
just
head?
did it and just.
Did it, yeah. Somebody then like drew me in
Really?
action. Yeah.
I wish I could have seen it.
All right. So we've got here 8x plus 8 plus 12x squared. all over 12x squared times x plus 1.
Ooh, wait, I see. 12x squared. We can.
I didn't hear what you said.
There's two.
No. Why? Why?
Oh, no.
They've got a legitimate question. We got 12x squared on top and bottom. But the one on top's part of a trinomial, isn't it?
Yes.
Can't think of part of trinomial. But good thinking. Good thinking. Good thinking.
What the heck?
These make me angry.
You got a 35 this year?
It's like,
Yeah.
You just thought you knew.
Thought you were.
Pick on a binomial.
No.
You just thought you were stupid.
Pick
Yeah,
one
I
mono.
can swear one.
That's
Yeah.
it. No binomial.
I think you got a 20.
So just think mono, you can pick on that.
Let's say you got a 35
Now
this year.
let me tell you that we can. While Grant made me think for a second, we can reduce this a little bit. Very good. On the top, listen. On the top, look at what Lainey Joe saw. That has the GCF on the top. GCF on the numerator would be 4. So I'm going to write these in order as I take the 4. If I take that out of the 12x squared, that would make a 3x squared. I take it out of the 8x, that'd make a 2x and then a 2. All over 12x squared times x plus 1. Now this is what, the reason that was a good idea, what Grant was talking about. Now we can reduce those monomials, right?
Ooh.
So it goes away on the top. So you just got 3x squared plus 2x plus 2. On the bottom, that 4 over 12 reduces to 3.
Wait, why'd you cancel? Wait, what? Do we have to? Oh,
Yes, if it can reduce, you have to reduce it.
Why'd you cancel the 4?
I reduced. 4 over 12 reduces to 1 over 3.
Is it,
You do know 4 over 12 is 1
Yeah.
over 3. That's not.
but you.
But what?
How'd you get 3 over 3? You just said 1 over 3.
4 over 12 right here.
Okay.
Changed to 1 over 3. This 3 is the same.
The one's not
okay.
there.
Okay.
You guys.
I can already tell you right now, this test over this ain't gonna be pretty.
So you're already quitting. That's a great
I'm
attitude.
not
quit it on the last
one.
one.
It's not gonna be
That
pretty.
kind of blew my mind. What'd you make on the list here?
95.
Boom.
Got it.
I love math.
Wow,
You are a
It's a 2.
I thought she was a 2. I was just thinking that. So it made me giggle.
Giggle is such a funny word when you think about it. Because when you're like, oh, it made me laugh. But then you're like, oh, it made me giggle. And you're like, oh, it made me like chuckle or something like that, you know? It's just funny to laugh.
Alright, so we got x plus 2. Listen. X plus 2 over 2x minus 2 minus negative 2x minus 1 over x squared minus 4x plus 3. No. Okay, so it's a subtraction problem with fractions. Is there a common denominator? No. So what we need to do is factor our denominators to see what parts we have.
So,
So what's the GCF on the bottom left?
x plus 1.
What's the GCF on the bottom left? 2.
Yeah, 2.
So all I'm going to do on the bottom left is take a 2 out. Okay, I've not done anything other than just factor so I can see what parts I have, so I can see what I'm going to have to give to it in a little bit. So over here, I'm writing my numerator again. Is there a GCF on this bottom right? No, so I'm looking at a trinomial. I'm looking at my a times c. What multiplies to make 3, but adds to make a negative 4. Negative 3 and negative 1. Okay, so now we've got all our parts out. getting those parts laid out will help you see what your common denominator needs to be. So my rule, and a good thing to think about, is if it's in one of your denominators, it's got to be a part of your common denominator. So I'm going to go ahead and set this up. I got to have a 2 on both of them because that one's got a 2. Okay? I got to have an x minus 1 on both of them. Okay, so I've looked at everything on the left. I'm moving over to see if I got everything on the right. Nope, I got to put an x minus 3 on both of them now, don't I?
Yes.
Okay, now the next thing on the right is x minus 1, but hey, I've already put that, so I don't put it again. Okay, so that's what your common denominator is. Alright, so on the left, are we ready? It already had the 2, so that's not new. It already had the x minus 1, so that's not new. The new thing is x minus 3. So since I put a new x minus 3 on the bottom, I got to put it on the top also. Okay, on the right side, we have the x minus 3s already. We had the x minus 1s already. So I put a new 2 down there. Since I put a new 2 down there, I got to put a new 2 on the top also. And you could have put that 2 on the top on the back. I just put it on the front because I know I'm going to have to distribute in a minute, and I like to distribute from the front. Okay, before we start, we got common denominator now, so we're going to be able to subtract here in a minute. But I need to go ahead, if I'm going to subtract, I need to go ahead and multiply this numerator. Yeah. So that makes an x squared. When I FOIL that, that's a minus 3x and a plus 2x, which is a minus x. And then I got minus 6. Now I'm subtracting, because it's a subtraction problem. So I'm subtracting negative 4x minus 2. Okay, can I simplify the top some more? Can I simplify the top some more? Yeah? Okay, so, whoops, we've got x squared. Now I've got negative x minus negative 4x. So I'm looking at negative x minus negative 4x. What's negative x minus negative 4? Positive 3x. Okay, then I've got negative 6 minus negative 2. That is negative 4. Oh, I put that parentheses there and not there. Let me erase that. I think there's probably more that can be done here.
Of course there is, because there's never enough.
I could multiply the denominator out, but what I'm thinking is maybe after all of this fun times, I can actually get to do some ninja math. So if I'm going to be able to do some ninja math, that means that I don't want to multiply the denominator out. Instead, I want to factor the numerator to see if there's any same parts that could multiply. So I got to check and see. I don't know. It might not can. A times C is negative 4. Are there any factors of negative 4 that add to a positive 3? Negative 1 and 4. I wrote that. Positive 4.
Negative 1.
Very good there, Mr. Cross.
Doesn't that feel great?
So it'll be x plus 4 over 2 parentheses x to minus 3.
You got it, sir.
My brain really is That's like my brain's doing a workout, like some CrossFit, you know?
I felt.
Wait, you're so twins.
Then like half the class, like do full class.
Right there.
I had a bag seizure last night. I swear. I like stretched out in bed. And my lower back
Yeah.
just I should have lay there and not move. I felt like I was paralyzed. I could like touch it and feel it twitching.
What is that?
There's no such thing as that.
No.
Please tell me.
It's a factor on. It's a
All right, we got 5 over, shall be quiet. We got 5 over x plus 4 over 1 over x plus 4 plus 2 over x. So what a problem like this does is a few things. It combines what we've talked about so far in this short period with what we did Tuesday. And what they call this is a complex fraction. And that should be a good name. It's fractions within fractions, and complex means complex. So this is a complex fraction. We learned Tuesday, we didn't learn it, we reviewed Tuesday that when you divide, that's the same as multiplying by the reciprocal. So what we're going to ultimately do is take what's on top and multiply it by the reciprocal of what's on bottom. But this bottom is the bad piece, because this bottom has 2 denominators. So we need to be able to get the top to have 1 denominator, and it does. X plus 4, even though that's a binomial, that's just 1 denominator. So we got to get 1 denominator on the bottom. Go ahead, Grant.
Could you name your math to plus 4?
No, because it's got this addition sign down here. So what we're going to do first off, we're just going to put the top on hold. The top is okay because it has 1 denominator. So we got to treat this bottom like what we've been doing so far this class period. We need to get a common denominator out of the bottom. So the top's on hold. We're not even worried about that now. I'm just looking at the bottom. So on the bottom, I've got an x plus 4 on the left. And I got to put that on both sides. And then I got an x on the right that's not part of the binomial. So I've got to put that on both sides. Okay? Alright, so over here with the 1, it already had the x plus 4. What was the new thing we put? An x. So with that 1, I got to multiply it by x. 1 times x is just x. On the right with the 2, I already had the x. What was the new thing I put down here?
Plus 4.
An x plus 4. Okay, I was going to go ahead and distribute that in my brain, but some of y'all are still behind, so you need to... Now we would distribute that. So that would make 2x plus 8. Now down here I've got a common denominator.
Yes.
So 1x and 2x, this is going to, this whole box is the same as 3x plus 8.
Over x plus.
Okay, so this replaces that box.
Oh.
So you've got a new problem now. I'm going to pause for a second, let you get caught up, and then I'm going to rewrite our problem that we're looking at.
So it'd be 5x over 4 over divided by 2x plus 8 over x plus 4 over x parentheses x plus 1.
That doesn't exercise your brain. Alright, so my new problem now, I'm going to keep, remember this we talked about, I'm going to keep the numerator 5 over x plus 4. I'll scoot it up in a second. I'm going to change this division to what? Multiply. Then I'm going to take the reciprocal of my new denominator. So x times x plus 4 over 3x plus 8. Now, This is the stuff we did Tuesday. I could multiply straight across the top and straight across the bottom, but Tuesday we learned sometimes it's easier to simplify stuff out first so you can get your ninja sword out here, right? So all we're left with on top is 5 times x. All we're left with on bottom is 3x plus 8. So that combined today's stuff and Tuesday's stuff and called it a complex fraction. Woo-hoo. No, we're not done. Jeez Louise.
I don't know if my brain can take.
Hey, there's dollar
brain is
counting
still
today.
Yeah, my
They're all on
That's unfortunate.
all 6 and
It's not that big. It's only that big. Gosh, Chloe,
Okay, so it's not a complex fraction going back to just today's stuff right now. We've got x plus 3 over 2x minus 4 minus negative 3x plus 1 over x squared plus 2x minus 8. Alright, so what do I need to do to get started? Okay, good, we're going to simplify the denominators. So on the left side, what can I do to see this one's parts? Take out a 2, very good. Okay. Not done anything nobody can't handle yet. On the right, rewrite that numerator. There's no GCF in that, so I'm doing my a times c. I need what multiplies to make negative 8, but adds to make a positive 2. Positive 4 and negative 2. Very good. Now, I talked to y'all about this on Tuesday. Remember, math is, y'all think math is mean to you, but you had an x minus 2 over here already. So I would be betting you're probably going to have an x minus 2 over here. So if you were struggling to find those factors that Lane and Joe didn't have any trouble with, think about, well, one of them's probably got to be x minus 2. And that was, we're good on that. So now we got our back taken apart. We see all the parts laying out. So if it's on one side of the denominator, we got to have it on both. So I'm just going to start filling in my common denominator. I'm going to bring that 2 down. I'm going to bring that x minus 2 down. Let me go put those on the other side also. Okay, and jump over here to the other side. There's an x plus 4 I got to put. And now I see an x minus 2, but hey, I've already put that. So I don't put it again. Okay, we good on our common denominator? Yep. Alright, on the left, I'm going to bring down what was already on top, the x plus 3. Now I'm going to see what new piece I put on the left side. Okay, the 2 was already there, check, check. The x minus 2 was already there, check, check. But hey, this x plus 4 is new, so I got to put it on the top. Okay, on the right, I'm going to bring down that negative 3x plus 1. Now let's see what new thing we added. X plus 4 was already there. X minus 2 was already there. But wait, this 2 wasn't. So I got to put a 2 on the top. Now, there's no new math in this. What we're going to do now, multiply these two, because that's what it means when there's no sign between them. We're going to FOIL those, multiply those. We're going to distribute that 2. And then if we have any like terms, we're going to subtract them. So that's not anything new. Okay, just be careful with your multiplication. I'm going to FOIL this left side. Gets me an x squared. Here I've got a 4x and a 3x, so that makes 7x plus 12. And I'm going to be subtracting negative 6x plus 2. And that's all over my common denominator. Okay, So, like terms that I can combine up there with that subtraction sign. 7x minus negative 6x.
That's X.
No,
13.
so 13x. 12 minus 2. All over. Let me scoot that up. I'm sorry. Here we go. I think a little too far. Okay. Now the last problem, we got to do some ninja math. So I would look here and I would say, well, I wonder if I'll be able to do any ninja math here. Are there any factors of 10 that add to 13? You just got 1 and 10, that doesn't add to 13. 2 and 5, that doesn't add to 13. So I don't have any ninja math that I can do. So I'm done. That is your answer. Some people might multiply the bottom, but if I've done all of this work, the only way I would do more is if it was multiple choice and that wasn't a choice. If there's a blank, this is a correct answer, right? Okay, okie dokie, okie dokie. Yeah, and that one thing you need to keep playing in your brain is we're not doing anything new. It's just a lot of steps putting all this stuff together. But there's not any new, we didn't make up any new math rules or have to get out any dictionaries or encyclopedias or Googles or anything. So nothing new on that. Okay, but because there are several steps, we got to practice this a lot more. Here's the plan for going forward with this same adding and subtracting. We're going to do the adding and subtracting again tomorrow. A couple of different things we're going to do with it. We're first off going to watch a video. Okay, so if you didn't understand something from me, maybe you'll understand it off the video. After the video's over, I'm going to give y'all lots of them to practice on your boards with your buddies. Okay, y'all do some good practice when y'all do that. So we'll look at that. Okay, so same stuff tomorrow. First with the video, second on your boards. Everybody okay? I think we need a couple of days on it, Garrett. Let's see. I wasn't throwing you under the bus yet.